Today's topic is waves and sound and its properties. Introducing waves. A wave is a disturbance in a medium which moves from one point to another and carries energy without a net movement of particles. It may take the form of elastic deformation or a variation of pressure. The example of wave is a rubber cork on the water that goes up and down. When a rock falls into the water, creates a ripple. Particle motion of mechanical waves are of two types as follows. First one is the transverse waves and second one is the longitudinal waves. Let's see first one. First is the transverse waves. A particle moving is perpendicular to the direction of wave motion. This type of wave is a mechanical wave. Example is light and Mexican wave in a stadium. It means that the motion of a particle in a wave, propagation of wave, that is perpendicular to the direction of a wave motion. The second one is longitudinal waves. It means particles travel parallel to the direction of wave motion by means of successive compression or elongations. Longitudinal wave is also a mechanical wave and the example is sound wave in the air. That is, the transverse waves are perpendicular to the wave motion and longitudinal waves are parallel to the direction of wave motion. Next one is the sound. Sound needs a medium to propagate. The matter or material through which sound propagate is called a medium. Sound propagate in a medium. When particles vibrate about their mean position, it pushes a region of compressed air, creating a region of high pressure, followed by the region of low pressure as the particle retreats to a mean position. That is, sound particles having the motion which is parallel to the direction of a motion of a wave. When particles vibrate, then it pushes the air and creating a region of high pressure and followed by a region of a low pressure as the particles retreats to its mean position. The next term is time period. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called a time period. The SI unit of time is in second. The next term is wavelength. The distance between two successive crests or troughs or successive compression and rarefaction is called wavelength. That is denoted by lambda. The SI unit of wavelength is meter. The next term is frequency. The number of compressions or rarefactions per unit time is called as frequency. That is, the SI unit of frequency is hertz. The SI unit is hertz per second. The next term is amplitude. The magnitude of disturbance in a medium on either side of a mean value is called the amplitude, which is denoted by A. As shown in the figure below, the unit of amplitude will be the density or pressure. This is the propagation of wave where amplitude, wavelength, time period, direction of propagation and time are described.